Hello class, we're on module 7 using chapter 10 out of Knapp's textbook. We're going to be talking about the chi-square. Don't pay attention to that. That's an old video up there. There are 3 activities in this module. We're going to solve statistical problems for categorical data using the chi-square. We're going to continue the course project by you'll be providing a sample table of data, and then adding 3 to 5 research questions and hypotheses. And then you'll be answering a set of questions about the chi-square terms and procedures. The chi-square, let's talk about that first. Chi-square shows a relationship between 2 categorical variables. And up until now, we've been using continuous or scaled variables for most of our analyses. This is where we get to use categorical variables. And for instance, the chi-square can be performed on data between gender and ice cream flavors. Gender is completely categorical. Girls, boys, there's no numerical value to them. They're not ordinal in any way. Ice cream the same way. Chocolate, strawberry, vanilla, you can't add say chocolate's on a scale of ice cream, chocolate's a 5, strawberries a 3, and vanilla's a 1. You just don't do that. I guess you could do it, but it's not appropriate. Categorical variables are dichotomous. They're also polychotomous. I don't know why we had just that there, but by dichotomous, I mean one of the dependent variable is a girl and a boy, or social economic status, high and low. Here's one that's polychotomous. School duration schema, traditional, year-round, and 4-day week. So there's 3 types of schools you can go to. Voter status, opinion, yes and no, attendance, present and absent, personages, the good, the bad, and the ugly. Wasn't that a movie? I think it was. Here's an example. Let's look at an example of a chi-square. Acme Creamery wants to discover if girls and boys have the same ice cream flavor preferences. In other words, is gender, girl and boy, a relevant factor when it comes to favorite ice cream flavor, chocolate, strawberry, vanilla? Is there an association between ice cream flavor and girls and boys? Or are they independent of one another? I'll explain that in a moment. Hypotheses, these are more formal. There is no significant statistical association between gender and ice cream flavor, and preference at an alpha of 0.05 or less. And our motivated hypothesis, there is a significant statistical association between gender and ice cream flavor. Most of the time, not most of the time, but often we use surveys to gather data. And here's our survey for this particular chi-square demonstration. What is your gender, girl or boy? What is your favorite ice cream flavor, chocolate, strawberry, vanilla? And let's see what happens. Well, we have a pretest. We're going to have to use that data in a moment. In each cell we'll have to see what a cell means too. Check after chi-square test is run. There's a pretest checklist, one thing. The end value for the cells. Check after chi-square test is run. We'll see what that means too. Here's a almost contingency table. It's not quite. We'll use the term contingency table, but this is not there yet. This is a 2 by 3 table. 2 rows and 3 columns. 2 by 3 table. Chi-square table. And we need to have at least 5 elements. 5 votes, if you will, or 5 people saying they like chocolate ice cream or vanilla or one or the other. Here's the data that we got back from that survey, 22, 10, and 14, 10, 30, and 10. Well, it looks like we have 5 in each cell, so it looks like we're ready to go with this chi-square business. Here's an example of one that has, looks like only 4 in one of the tables. What do you do when you don't meet the opening checklist? Well, you know we've got a fix for that. Let's go on through this and we'll talk about the fix as we come to it. When you go to run the test, you do the same old, analyze, descriptive statistics, crosstabs. So it's analyze, descriptive statistics, crosstabs. Crosstabs is a new area you have not worked in, but crosstabs gives you those contingency tables. And that's what the SPSS examines is that contingency table relative to the data you're looking at and the expected data that you should be looking at. When you go on with that test, you'll pick the chi-square, push continue, and go on. And remember, the pre-test is in greater than 5 per cell. Check after the chi-square test is run. We'll do that, and I'll show you why. This is part of the contingency. This is a real contingency table here, and the reason we can tell the difference is because this has column totals and row totals. Excuse me. The computer works with these row totals and column totals to determine what we call expected values. Here's the same data, and here's the totals in each row, each column, and each row. But notice, here are the expected values. So from this conglomeration of data here, SPSS inside, it's kind of like your TV works. You know, you can use it, but you don't know what's going on inside. The same thing's happening here. They come up with what are expected values. It's really not hard to calculate those on spreadsheets. Matter of fact, that's how I calculated these. But you can't simply add 2 together and divide by 2 or something like that. What would that be? 10 and 22 is 32. It'd be 16. That'd be pretty close. We've got to, that would be pretty close. As a matter of fact, if later, that's a trick you can use to help you decide if you've met the expectation of the pretest. But look, what happens if it's less than 5? And the expected values are greater than 5. Look, these are the values in this table. And I've changed it a little bit. I changed this one to be less than 5. But when I ran the expected values, look what happens. I get an expected value for boys of 14.7. Let me tell you right here, if your expected values come out to be greater than or equal to 5, then you can still use the chi-square test and measure it on the Pearson value, which we'll talk about in a minute. Now, let's just check that one again. 22 is 26. 26 divided by 2 is 13. Well, this is a nonlinear kind of thing that happens here, so I was just trying to do that. But if you can add, honestly, if you can add the values and divide, if it's a 2 by a table, and divide by 2 and get a value greater than 5, you're probably going to be all right with the expected values. Just a little trick. Chi-square pretest, let's get back to it here. We're going to analyze gender and ice cream flavor preference to a chi-square table. Each cell needs to be at least 5. This is our set of data that we got from that survey. And while we're talking about that, let's go back to that. This is the data from a survey, and we're measuring of the chi-square. Most oftentimes, surveys are measured using the chi-square. If you do a survey, about 80% of the time you're going to end up doing a chi-square analysis. Okay, results of that test in the machine. We know we said we don't know what went on in there, but something did. And the Pearson chi-square is what you look at most of the time, especially if you meet the opening criteria that the values were greater than 5.001. That's highly significant. There's another one called the likelihood ratio. What do you want to bet we don't look at that if the n values don't meet 5? I bet we do too. The chi-square makes some fine graphs for you. It'll give you some nice colorful graphs and show you the relationship between girls and boys for each of the flavors of ice cream. And here's an abstract of the work. According to the survey, 96 children were detected at a statistically significant difference, p equal to 0.001, alpha at 0.05. And in this thing, we determined that the 46 girls surveyed most preferred chocolate. And of the boys that were surveyed, I think they selected strawberry, didn't they? 50 of our sample predominantly selected strawberry. Yeah. Here's 2 ways to present that. Here's your table. And no matter which way you present this, that table is going to come out the same. You're going to get the same significance. That is, if you make your initial table, chi-square table or data table, the girls and boys on the column over here on the left, and what I call the independent variables across the top, you're going to come up with that value. If you move those over here to the left and the girls and boys over the right, you still come up with the same values. It's the math's the same. I'll tell you what I like to do, and I'll show it to you in a minute about where to put the variables. Here's a graph of that first table. It compares boys and girls. This table compares preference for chocolate, strawberry, and vanilla based on the gender. So you can look at it that way. Here's my preference, and it's most people's preference. When you make a chi-square pre-contingency table, let's call this, put the dependent variables down the left and the independent variables across the top. You don't always have to do this, but about 90% of the time that'll work out best for you. Okay, let's go to part 2 of what we're going to do here. We're going to continue with the course project, and I'm going to show you how to do some of these things. But based on the information that you've derived and put forth so far about purposes, significance, overarching questions, and so on, you're going to do these 6 things. Provide from 3 to 5 research questions based on your overarching research question. Provide 3 to 5 hypotheses based on your overarching hypothesis. What data would you're going to have to figure this out. It's time to fish or cut bait here. What data will you need to answer these research questions and determine the outcome for your hypotheses? You're going to have to come up with that. So you can imagine that data from your experiences, or you can get some of that data from your school district, or you can look at the state's data tables and you can get some data. But you need to come up with some data. It says construct a fictitious data table, and you will. A data table for all the pieces of data you mean. And it could be like a 4 or 5 column table with different numbers in it, and maybe 3 or 4, 5, 6 rows. And I'm not talking about chi-square test here, but you'll have to display your data. You can do this in SPSS or Excel. And I say here, you'll probably use Excel. I did, and I wished I had done it in SPSS, the example I'm going to show you. Provide the descriptive statistics for the sample that you come up with. In other words, you're needing to do the mean, the median, the mode, the range, the standard deviation. We'll look at that in a minute as well. And then for each hypothesis, indicate what statistical tool you might use. Now, we haven't covered everything, so you may not know, and that's not going to take points away from you. But if you know, look at it. If you can find a study like yours and whatever they use to analyze it, you put that down. Okay, here's an example. Provide from 3 to 5 research questions, and the same for hypotheses derived from your overarching research question, which the hypothesis was derived from. For instance, if your overarching research question was how is student performance for students receiving special program services affected by the school year duration? Now, special program services could mean a lot of things to a lot of people. Before you get to this point in your study, you will have defined these kinds of terms, what you mean by special programs and services, the ones that you are going to look at. And when you talk about school year duration schema, you will have talked about that. You will have defined all these terms before you get here. Okay, what would be a good research question? Not an overarching one, but a specific one. If your overarching research question was how is student performance for students receiving special program services affected by school year duration, maybe more specifically you would say, how is student performance as measured by the the I started to say Cooter Richardson, but that's not it. But some annual achievement test or some score the school has to measure its achievement for high and low SES students. Well, we can do that by a free and reduced lunch rate, or the state probably has a level for that. Affected by school year duration schema. In other words, the traditional 9-month school, the year-round school, and the 4-day week school. So we've got these 3 choices. And we got 2 socioeconomic status. Hey, this is a candidate, believe it or not. It's a candidate for a couple of things, but it's a candidate for chi-square, and it's a candidate for a multiple ANOVA, but we'll come to that. HO1, what is your hypothesis? There is no significant difference in the achievement level as measured by the whatever the achievement measure is. You'll have one for high and low SES students among students attending school in a traditional 9-month school, a year-round school, or a 4-day-a-week school. And there you go. You're all set up. And you just need to find out what your overarching